This is SpaceTime Series 27, Episode 54, for broadcast on the 3rd of May 2024. Coming up on SpaceTime, the oldest evidence yet for Earth's magnetic field. Scientists find Jupiter's moon Io has always been volcanic, and how Eclipse projects are shedding new light on the solar corona. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Geologists have uncovered ancient rocks in Greenland that bear the oldest remnants of Earth's magnetic field ever found. The findings, reported in the Journal of Geophysical Research, show that these rocks appear to be exceptionally pristine despite having preserved their properties for some 3.7 billion years. The authors have determined that the rocks retain signatures of a magnetic field with a strength of at least 15 microtesla, and that's similar in magnitude to the Earth's magnetic field today. The discovery potentially extends the age of the Earth's magnetic field by hundreds of millions of years. The study's authors say the findings may shed light on the planet's early conditions, which helped form life and allowed it to take a hold. One of the study's authors, Claire Nichols from Oxford University, says the magnetic field is, in theory at least, one of the reasons Earth is unique as a habitable world in our solar system. You see, the magnetic field protects life on Earth from harmful radiation from space and from the constant erosion of the atmosphere by the solar wind, a stream of charged particles continuously flowing out from the sun. Put simply, it helps retain the oceans and atmospheres essential for life as we know it for long periods of time. Previous studies had shown evidence for a magnetic field on Earth that's at least 3.5 billion years old, and this new study extends that significantly by a further 200 million years. The study's co-author, Benjamin Weiss, says it's important because that's the time when scientists think life was emerging on Earth. Weiss says if the Earth's magnetic field was around a few 100 million years earlier, it could have played a crucial role in making the planet habitable. Today, Earth's magnetic field is powered by its molten iron core, which slowly churns up electric currents in a self-generating geodynamo. The resulting magnetic field extends out and around the planet like a protective shield. Scientists suspect that early in the planet's evolution, the Earth was able to foster life in part due to an early magnetic field that was strong enough to retain a life-sustaining atmosphere and simultaneously shield the planet from damaging solar radiation. However, exactly how early and robust this magnetic field was has long been a subject of debate among scientists. In 2018, Nichols and colleagues undertook an expedition to the Isotopes supercrustal belt, a 40-kilometre-long stretch of exposed rock formations surrounded by towering ice sheets in the rugged and isolated southwestern part of Greenland. There, scientists discovered some of the oldest preserved rocks on Earth, which have since been extensively studied in the hopes of answering a slew of questions about Earth's ancient environment. For Nichols and Weiss, the objective was to find rocks that still held their signatures of the Earth's early magnetic field, which was imprinted on the rocks when they first formed. Of course, sedimentary rocks form over millions of years, as grains of sediment and minerals accumulate and progressively pack together and are buried under subsequent deposition over time. Any magnetic minerals, such as iron oxides that are in these deposits, follow the pull of the planet's magnetic field as they form. This collective orientation and the imprint of the magnetic field it has are therefore preserved in the rocks. Problem is, this preserved magnetic field can be scrambled or completely erased if the rocks subsequently undergo extreme thermal or aqueous events, such as hydrothermal activity or plate tectonics that can pressurize and crush the deposits. Determining the age of a magnetic field in ancient rocks has therefore developed into a highly contested area of study. To get to rocks that were hopefully preserved and unaltered since their original deposition, the authors sampled from rock formations in the Isotopes supercrustal belt, a remote location right up against the ice sheet which is only accessible by helicopter. The expedition returned to the lab with whole rock samples of banded iron formations. That's a type of rock that appears as stripes of iron-rich and silica-rich rock. The iron oxide minerals found in these rocks can act as tiny magnets that orient with any external magnetic field. Now, given their composition, the authors suspect that these rocks were originally formed in primordial oceans prior to the rise in atmospheric oxygen levels around 2.5 billion years ago. Back then, there wasn't oxygen in the atmosphere, so the iron didn't oxidize easily. Instead, it remained in solution in the oceans until it reached a critical concentration, and then it simply precipitated out. Nichols says the iron raining down out of the oceans was deposited on the seafloor, eventually becoming part of the rocks they recovered. Previous studies used uranium-lead dating to determine the age of the iron oxides in these rock samples. The ratio of uranium to lead gave scientists an estimate of the rock's age. Uranium gradually radioactively decays into lead. Because scientists know the half-life of uranium, it gives them an estimate of the rock's age. And the analysis found that some of these magnetized minerals were likely to be around 3.7 billion years old. Now, the authors had already shown that the uranium to lead age also dates the age of the magnetic record in these minerals. So they then set out to determine whether the ancient rocks preserved magnetic fields from that far back, and if so, how strong that magnetic field might have been back then. Now, to do this, the samples are firstly demagnetized, and then slowly remagnetized at known levels, allowing scientists to compare the gradient of the demagnetization to the gradient of the remagnetization in the lab. And that gradient tells you how strong the ancient magnetic field originally was. This allowed the team to establish that the rocks likely harbored an ancient 3.7 billion-year-old magnetic field with a magnitude of at least 15 microtesla. Now, today, Earth's magnetic field measures around 30 microtesla. So that's half the strength, but the same order of magnitude. The fact that it's of similar strength as today's field implies that whatever's driving Earth's magnetic field hasn't changed massively in power over billions of years. The team's experiments also showed that the rocks retained their ancient magnetic field despite having undergone 2 subsequent thermal events. Any extreme thermal event, such as a tectonic shake-up of the substructure or hydrothermal eruptions, could potentially heat up and erase the rock's magnetic field. The authors found that the iron in the samples likely oriented and then crystallized 3.7 billion years ago in some initial extreme thermal event. Then around 2.8 billion years ago, and again 1.5 billion years ago, the rocks may have been reheated, but not to the extreme temperatures that would have scrambled their magnetization. These results also raise questions about how the ancient Earth could have powered such a robust magnetic field. While today's field is powered by crystallization of the solid iron inner core, it's thought that the inner core had not yet fully formed so early in the planet's evolution. Weiss concludes that it seems whatever was generating a magnetic field back then was a different power source to what's generating it today. And that raises some interesting questions. This is SpaceTime. Still to come, scientists find Jupiter's moon Io's always been volcanic, and Eclipse Project shedding new light on the solar corona. All that and more still to come on SpaceTime. A new study has shown that Jupiter's Galilean moon Io has always been volcanic. The findings, reported in the journal Science, show that sulfur and chlorine isotopes in Io's atmosphere indicate that it's been volcanically active for its entire 4.57 billion years of existence. The findings are offering new insights into the moon's history. Io is the most volcanically active body in our solar system. This extreme level of volcanic activity is the result of massive tidal heating from friction generated within the moon's interior as it's constantly stretched and squeezed by the gravitational pull of Jupiter and its neighbouring moons Europa and Ganymede. However, how long ago Io hosted such extensive volcanism has never been fully understood. Due to the moon's current level of volcanic activity, the surface of Io is constantly being reworked. On Io, instead of weather reports, you'd have geology reports, with mountain building in the east, volcanic lava lakes in the west, fresh eruptions in the north, and tectonic upheavals in the south. All this leaves a geological record at most just 1 million years or so old. So, instead, stable isotopic measurements of volatile elements in Io's atmosphere are being looked at because they could provide information about the history of volcanism on Io. So, a team led by Catherine DeClaire from Caltech, the California Institute of Technology, used Alma, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, to observe the gases in Io's tenuous atmosphere, and used them to determine the stable isotopic ratios of sulfur and chlorine-bearing molecules. The authors found both elements are highly enriched in heavy isotopes compared to average solar system values. That's due to the loss of lighter isotopes from the upper atmosphere as the material is continuously being recycled between Io's interior and atmosphere. The findings indicate that Io's probably lost somewhere between 94 and 99% of the sulfur that undergoes this outgassing and recycling process. They say that would require that Io must have had its current level of volcanic activity for its entire existence. This is SpaceTime. Still to come, Eclipse Project shedding new light on the solar corona. And a new study has found that nearly half of China's major coastal cities are sinking. All that and more still to come on SpaceTime. Scientists around the globe are continuing to sift through the data collected from the solar eclipse which spread across North America in early April. The breathtaking display came just as the sun was nearing the peak of its 11-year solar cycle. The eclipse made landfall on the Mexican Pacific coast before arcing up through the southwest, midwest, and New England regions of the United States, then across eastern Canada, before finally heading out into the Atlantic Ocean near Newfoundland. As well as more than 40 citizen science projects, NASA launched a small armada of rockets, jets and drones to monitor the spectacle in great detail. These included 3 Blackbird 9 sounding rockets from the Wallops Island Flight Facility on the Virginian Mid-Atlantic coast, a specially equipped drone from Fort Drum in New York State, and NASA's high-altitude WB-57 jet. The Southwest Research Institute executed 2 experiments by land and air, collecting unique solar data from the eclipse. There was CATE, its Citizen Continental America Telescope Eclipse project, which engaged more than 200 citizen scientists to make a continuous 60-minute high-resolution movie of the eclipse. A nearly simultaneous investigation used unique equipment installed on NASA's WB-57 high-altitude jet, which chased the eclipse shadow across America, making observations of the sun's outer atmosphere corona, which were only accessible using high-altitude aircraft. Total solar eclipses offer unique opportunities for scientists to study the hot atmosphere above the sun's visible surface. They allow scientists to view complex and dynamic features of the sun's outer atmosphere in ways that simply aren't possible or practical by any other means. Thereby, they open new windows into science's understanding of the solar corona. And we just can't do these without an eclipse, because the light from the corona is usually overpowered by the intense glare of the sun itself, and some wavelengths of light are also blocked out by Earth's atmosphere. Luckily, the WB-57 can fly high enough to be above most of the atmosphere. Now, while NASA's jet was flying high up in the sky, the CATE project deployed a network of 35 teams of citizen scientists representing local communities along the eclipse path, the so-called line of totality. They deployed a small bucket brigade of small telescopes following the eclipse path across the country. Their scientific objectives required measuring the polarization of light or the orientation of oscillating light waves in the corona. Their telescopes were fitted with special polarizing filters baked onto every pixel of the sensor, allowing scientists to measure 4 different angles of polarization in the corona. Meanwhile, the airborne project to observe the corona during the eclipse from 50,000 feet aboard the WB-57 provided measurements that can't be made from the ground using a new suite of sensitive high-speed visible light infrared images. These were built by NASA's Langley Research Center and installed in the jet's nose cone. Looking at complex motions in the solar corona at new wavelengths and with new polarization measurements will help scientists better understand why it's so hot. The corona is millions of degrees Celsius, and that's hundreds of times hotter than the visible surface below, a curious paradox that's long intrigued the scientific community. The solar corona is also one of the major sources of eruptions which cause geomagnetic storms on Earth. These can damage satellites, cause power blackouts, and disrupt communications and navigation systems. so it's important to understand it better as the world becomes increasingly dependent on these systems. Dan Seaton, who led both projects for the Southwest Research Institute, says combining the airborne mobile data with the Kate observations provides a more complete picture of the Sun's mysterious corona. Co-researcher Emmy Caspi says both experiments required an enormous effort and precise timing to get the data they needed.
The odds of seeing an eclipse in your human lifetime, if you can't fly to one, if you can't travel to one, is actually quite small. We here at Southwest Research Institute are leading 2 exciting eclipse projects to chase the eclipse. One of them chasing it in the air, literally using NASA's WB-57 high-altitude jets. Outfitted with telescopes in the nose cones, fly at 50,000 feet, chase the eclipse at about 400 knots or 460 miles an hour. The second project is having the eclipse chase us. So we're deploy 35 teams of community participants, or citizen scientists as they sometimes are called, all the way along the eclipse path from Texas to Maine. Each team is getting a telescope, a camera, a mount, and other equipment, and training so that they can observe the eclipse as it passes overhead. And it'll be like a bucket brigade where each team sees the shadow right before the next team does, so that together, when we put all of the data together, we can get over an hour of totality, which is something that will allow us to study the corona. There's still a lot of open questions about the sun. One of them is why the corona is so hot. The surface of the star that we can see is about 6,000 degrees Kelvin, or about 10,000 degrees Fahrenheit, but the corona is millions of degrees. It's like being next to a campfire, and the further away you get from the campfire, the hotter it gets. It's counterintuitive. It's not something that we're used to thinking about. So by observing the solar corona during a total eclipse with high resolution and high speed and polarized light, like we're doing with our community participants in the Kate 2024 experiment, we're going to learn a lot of new information that will help us dig into these mysteries.
That's Amir Caspi from the Southwest Research Institute. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows that if you don't get as much sleep as you really need, a so-called short sleeper, you could be at a higher risk of type 2 diabetes even if you're a healthy eater. The findings reported in the Journal of the American Medical Association are based on data from 247,867 adults in the UK, finding that people sleeping less than 6 hours daily had a notably higher risk of developing type 2 diabetes compared to those who slept 7 or 8 hours. The authors also found that this increased risk was seen even in people with healthy diets, despite this factor usually reducing type 2 diabetes risk. Now, while this kind of study can't show cause and effect, the findings do show the importance of sleeping well and eating well, especially for those at higher risk of developing diabetes. A new study has found that nearly half of China's major cities are sinking. The findings, reported in the journal Nature, also show that a quarter of China's coastal land is expected to slip below sea level in coming decades. The land subsidence will affect hundreds of millions of people. Researchers say a range of natural and human factors are to blame, including the depth of a city's bedrock, groundwater depletion, the weight of buildings, and even the use of transport systems and underground mining. A new study shows that older adults with attention deficit hyperactivity disorder are more likely to be in a car crash, receive a traffic fine, or have to brake aggressively to avoid a collision. The findings, reported in the Journal of the American Medical Association, looked at data from 2,832 drivers aged between 65 and 79. Researchers collected data on hard braking events, self-reported traffic fines, and vehicle accidents over an average of 3.5 years. They found self-reported ADHD was associated with a 7% increased risk of hard braking events, a 102% increased risk of receiving a fine, and a 74% increased risk of being involved in a crash. The new findings are important, as most research into drivers with ADHD has always focused on younger people. And time now for what's got to be the silliest story of the week, maybe even the year. A part-time singer who claims she was stalked by a ghost, but later decided she liked it and apparently married the manifestation, has now divorced him. The entity anyway. I don't know what the correct pronouns are for this sort of thing. Now, the divorce came about because apparently this philandering phantom was unfaithful to her. Tim Mendham from Australian Skeptics says she's now starting a new career as a paranormal investigator. Well, of course she is.
This is a story where you start off with a deep sigh. It is one of the good ones, but this is why we call it a silly story of the week. This was a woman in the UK who's a singer who claimed that she was assaulted, really, by a ghost a few years ago, and they got to like each other a bit. They got married. This real woman and this ghost got married, but then she got a bit upset because the ghost's interest started wandering, and apparently he had the hots or the colds or whatever from Marilyn Monroe, right? And so he was being sort of a bit unfaithful to her in the ghost realm.
She could see right through him.
They had a falling out. They got divorced. I'm not quite sure where they got married and where they got divorced, which particular court or sort of place where you can marry a ghost and divorce a ghost. And so she got divorced, and now she is now setting herself up as a paranormal investigator. And apparently this ghost is this Victorian-era soldier named Eduardo. Doesn't sound very Victorian-era, but never mind. It's now looking sublimely upon her and smiling at her and saying, yes, it's all settled down now. We've got over our divorce, our messy sort of unfaithfulness, and he is now giving her his blessing, and she's carrying on as a paranormal investigator, talking with other ghosts. But apparently he's not very upset with that. The interesting thing is that she had this story out a while ago of being married to this fellow, and now she's got this divorce story. And it tends to come out at the same time as she's a singer and she's got an album coming out. And I wonder, I can't impugn her motive. I don't know. Maybe she seriously believes this stuff. But it also ties in very well with a bit of self-promotion for whatever reason. And apparently she has followers.
When we spoke about this last time, a couple of months ago, you were questioning what the quality of the album was likely to be like if she needs this sort of promotion.
Yes, I know. I haven't heard the music. I don't know. I must have got no idea whether it's sort of ethereal music or whether it's heavy metal or what. This is seduced, married, divorced, now blessed, and the source of a whole new career for this person. So I don't believe it, personally.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.